Good afternoon, everyone. Welcome to our session on how to build, manage, and scale ML development with a web-based visual interface. I'm Rekha Sheshadrinathan. I'm a principal product manager here on AWS SageMaker, and I'm joined on stage today by Ram Vittal, principal solutions architect, and my colleague here at AWS, and Piyush Jain, executive director at JPMC. Before we get started today, I wanted to first tell you a short story about why this session might be relevant. Two woodcutters went into the forest to gather wood. They both started right at dawn, and they cut wood all the way to sunset. The only difference being that the second woodcutter disappeared somewhere between 12 and 1. At the end of the day, when they gathered their wood, they found that the second woodcutter had cut more wood. The first woodcutter was a little surprised, since he had been there for longer, but he thought it might just be luck. So the next day, they came back, and the same thing happened again. They cut wood right from dawn to sunset. The second woodcutter disappeared again, somewhere in the middle of the day, and at the end of the day, he still had more wood. So this went on for a few days, and finally, the first woodcutter said to the second one, "Okay, we're both here every day, from morning until sunset, and every day you still seem to have more wood than me. And I think it has to do with where you go in the middle of the day. Can you share your secret?" To which the second woodcutter simply replied, "Oh, I just go home to sharpen my axe." So the tools that we use can often impact our output and our productivity a lot more than we realize. And in this session today, we're here to tell you how we're building purpose-built tools for you in SageMaker to make you much more productive and successful with your ML development. So in this session, we'll first give you an overview of why we built SageMaker Studio and how it can help you. Then Piyush is going to go over how they're using SageMaker Studio at JPMorgan Chase, and he's going to share the architecture that they've deployed. I'll give you an overview of SageMaker Studio features. And finally, Ram will walk you through a detailed demo showing you exactly how to build, train, and deploy models using SageMaker Studio. Right, let's get started. So gone are the days when we heard about machine learning just in the context of web search. From autonomous cars to retail recommendations to fraud protection and drug discovery, machine learning is driving innovation in almost every industry we know of. And this is evidenced by the investment that we're seeing in machine learning. So according to this chart, the IDC saw that the global spend in machine learning went from almost nothing in 2013 to $50 billion in 2020. Which is a span of just 7 years. To put this in perspective, if you look at cloud computing took 12 years, or almost twice as much time, to reach the same level of investment. And these customers are investing in machine learning because it is driving innovation. However, these same customers who are spending all this money are also telling us that machine learning can be really challenging. So first, compared to traditional software development, which can be more linear, machine learning tends to be a lot more iterative and a really long workflow. So let's look at what an end-to-end machine learning workflow typically looks like. So you first start by preparing your data set for training. And your data is usually not always in the same location, right? It's usually spread in silos across your organization, and you need to ingest it from multiple sources. So you ingest your data from multiple sources, then you prepare and clean your data. Now it's ready for training. Well, then you need to select an algorithm. And there's lots of different algorithms to choose from, so you may experiment with regression models or deep learning, and you select an algorithm for training. Once you've selected your algorithm, you actually need to train the model, and you need to tune it to get the best performance, which means you need to experiment with different data sets, different hyperparameters, and lots of different combinations to get the best performance. Once you've done all of this, you've probably done hundreds of training runs. And it's difficult to remember which dataset parameters and which hyperparameters you used, what were all the combinations, and what metrics you got, right? Managing all of this can be a project in of itself. And once you're happy with your model and the performance, you now need to deploy that model to production. Depending on your organization, this may be when a machine learning engineer takes over. And often, machine learning engineers are writing a lot of code to build their CI/CD pipelines and to ensure that you're seeing in production the same level of accuracy that you saw in your dev and test environments, which means there's a lot of manual work and a lot of custom code that needs to be written. Now, you've done all of this, you've deployed your model to production, and your application is successful. That's awesome. But once your application is successful, you now need to scale your application for high availability and more traffic. You might need to deploy more models, different models for different sets of customers, different regions, and you now need to manage all of these models in production. Manage them, monitor them for bias, monitor them for drift. And you need to do all of this while making sure that you are meeting the security and compliance requirements of your organization and your industry. And this can definitely be very challenging. So to help our customers with the challenge of machine learning, we launched SageMaker Studio right here at re:Invent a few years ago. SageMaker Studio is the universal IDE for machine learning. Now, what do I mean when I say universal IDE? Well, it is a single pane of glass from which you can build, train, deploy, manage, and monitor your models. So, of course, you have your managed notebooks where you can author all of your code. But also, from that same interface, you can ingest your data, you can prepare and clean your data, you can run all of your training jobs, you can debug your training jobs in case something goes wrong. You can also manage and monitor all of your experiments. You can track your metrics, you can go back and forth between steps. Once you're done with training and you're happy with your model, you can register your model in a model registry. And then your machine learning engineer can also build pipelines, deploy the models, and manage and monitor the models, all from this same interface. Given how long the machine learning workflow is, and probably how collaborative this process is within your organizations, we've also designed SageMaker Studio for collaboration. So if you're a data engineer who wants to prepare your data within SageMaker Studio, you can use our native integration with EMR Studio or Glue Interactive Sessions to run petabyte-scale workloads right within SageMaker Studio. And once your data has been prepared, you can seamlessly transition to the data scientist who can train their models from that same interface. SageMaker Studio comes pre-installed with the SageMaker Python SDK, which means your data scientist can write a few lines of Python code to spin up a large-scale distributed cluster. We run your training scripts on that cluster, train your model, and then SageMaker will take care of spinning down that cluster so you don't have to manage that infrastructure. Once you're done training that model, you can register the model in model registry, and your machine learning engineer can take over, and they can build pipelines, deploy the models, and manage the models in production. So now that I've given you an overview of SageMaker Studio and the features, I want to hand it over to Piyush, who will tell you more about how they're leveraging SageMaker Studio at JPMorgan.
Thank you, Rekha, for explaining the challenges of the data scientists that they face today, and also explaining how Studio can solve the issues. So, hi everyone, I am Piyush Chan, and I am the Executive Director with OmniAI Training Platform in JPMorgan Chase. And today I'm going to tell you the journey we went through to enable Studio in JPMorgan Chase. So before I deep dive into the architecture and how we enabled, let me explain what OmniAI platform is. So OmniAI is a fully managed platform service that in JPMorgan Chase that enables the data scientist and machine learning engineers to build, deploy in cloud at scale, the machine learning models. Now the screen, on the screen, the image that you see is the homepage for OmniAI platform. And there is a bunch of options on the left-hand side menu. So there's an option to upload data from your local desktop into an S3. And while it is done, it's cataloged into a central metadata repository. It has options to manage and track your experiments in the experimentation tool. We also have a homegrown model repository, which is used by data scientists to register the model and also use it to promote the model into a serving environment, which is production environment. We also have option for data labeling, which is using SageMaker Ground Truth, and that helps the teams to create the labeling workflows and labeling jobs. And using the labeling jobs, the labeling team can label the data that can be used for training. We also have option for EMR and Spark processing, which data scientists use to create transient and persistent EMR clusters, and they use it for data processing, pre-processing, and post-processing during their training. Finally, at the top, you see option for notebooks. So we have an option for homegrown notebook service that is based on EC2. And this year, we also added option for SageMaker Studio. Now, let me go into the details of how we enabled SageMaker Studio in JPMorgan Chase. So we had to focus on two aspects. The first one is being a web interface, how Studio Notebook is accessed. So it's accessed from OmniAI UI, the training platform, the screen, the image you saw on the screen, the previous slide. So it has built-in controls so that the Studio Notebook is accessed securely. Then we have a custom SDK that is used on top of the SageMaker Python SDK. It hides the infrastructure details that the data scientist has to provide to create any training job, processing, or any type of SageMaker jobs, because they all take infrastructure inputs like KMS key, security group, VPC config, network config, right? All those things data scientists should not be worried about. So we use this custom SDK to provide a seamless experience on Studio Notebook. Next area of focus was security. So being a highly regulated company, we had to ensure that the risk of data breach or data exfiltration is minimized. So we ensured that the Studio pre-signed URL is expired in few seconds, and also it is being accessible only to the known network paths. We had to enable in a VPC mode configuration so that there is no egress to internet from the Studio environment in AWS. We also had to encrypt the EFS volume attached to the Studio domain, where the user directories for the data scientist are there, so that it's all encrypted with JPMC managed KMS key. We disabled the download button on Studio Notebook so that the risk of data exfiltration is minimized, especially in case of highly confidential data. We also had to control the egress from Studio Notebook. So the egress is allowed only for the known network paths. So we have to a bunch of things to make Studio Notebook more secure in Chase environment. Next, I'll deep dive into the architecture. So to enable Studio, we need to set up Studio domain, which is collection of user profiles of the data scientist. Now, to do the setup, we use infrastructure provisioning platform that creates the domain and the associated resources with the domain, like the role, the encryption key, the managed policy, the lifecycle configuration. And all of this is provisioned in 500 plus accounts. Now, each account means a team is for a team of data scientists. So there are 500 plus teams. And now going into the journey of the data scientist, so they go to the Omnia UI, and they will log on to the Omnia UI. They'll see the accounts they are a member of. They'll select the account, and they'll say, Open Studio Notebook. When they do that, it goes through OIDC and OAuth 2 provider, and the JPMC Chase Studio service will create the user profile and the pre-signed URL for the notebook just in time. Now, while this is being done behind the scenes using the lifecycle configuration, which is a bootstrap script, the custom SDK that I talked about a couple of slides back is configured so that Studio Notebook can access the code repository, the Python repository, model repository, the experiment management tool on-prem. Now, the second thing that is done behind the scene is the idle shutdown notebook extension is configured so that users can specify the idle duration. And whenever the compute instances are running more than the specified idle duration, that extension will kill those computer instances. So it saves cost for the user. Now, we also did performance testing on Studio. So what we did in performance testing and what we found was that in one account, so there are 500 accounts, in one account, there can be 100 notebooks launched in 7 minutes. That means each minute, 16 users can launch Jupyter app and kernel app. And in order to do that in every account, we had to increase the SageMaker limits, Studio limits, like number of user profiles and total concurrent apps in the user per domain. So this is just for one account. So in every account, we had to do that. Now, let me go into the features that we enabled from Studio. We enabled Data Wrangler, which is the visual interface to allow users to process data. We also, and Data Wrangler comes with integration with S3, Athena, Redshift. We also enabled Spark processing, PySpark processing jobs, so users can use that to create their transient Spark jobs to process data. We also enabled Feature Store, which is a self-service today. So if the user want, they can set up Feature Store and use with Studio. Feature Store allows creating a feature once and share and with many teams for use. We enabled Autopilot, which is the automated machine learning offering from SageMaker. So users provide data set in a structure format. They specify the target column, and the SageMaker does the rest of it. It will run the training jobs and give the candidate model, which can be fine-tuned later on. We also enabled experiments as an additional option, so users can use SageMaker experiments for tracking and managing experiments. We enabled debugger and profiler. Debugger is used by data scientists to troubleshoot their training jobs. If they see overfitting or vanishing gradients or similar problems in the training job, they can use debugger to take action. Debugger can notify the user or stop the training job. So it also helps reduce the cost on unnecessary iterations that the training job will do when the issue happens. Profiler helps them to look at the CPU, GPU metrics and utilization. So if there is a bottleneck, they can take action. We also enabled Clarify, which helps them do bias detection and model explainability. Bias detection is to detect any possible bias in the data set. And model explainability they use to identify the important columns that have the most influence on the training. We also enabled SageMaker pipelines, which is the orchestration tool data scientists can use within the studio environment to orchestrate their machine learning flow end-to-end, right from the data preparation to training, validation, and then deployment. We also enabled model monitoring. This is to allow data scientists to test their model monitoring code that they'll have to use in the serving environment. So they can create model monitoring, processing jobs, baseline, and test that all out in the training environment before they go and deploy that in the serving environment. So during the journey of enabling Studio in Chase, we had a tremendous support from the AWS team. We requested features which the AWS team implemented to enhance the security posture of Studio Notebook. We also requested features to improve the productivity of data scientists, like we asked for enhancing the experience on Autopilot UI. And the Studio team and the SageMaker team, they addressed many issues in the UI that we discovered, and especially in the lifecycle configuration, but because that's the key to implement certain security controls and also provide a seamless experience to the data scientist. So I'll quickly go into the roadmap that we have. So we want to enable Jupyter Lab 3. So that's the upgrade that we are planning to do. We also have VS Code server integration plan because on the homegrown EC2-based notebook service, we have VS Code server being used by the data scientists to do local training on the EC2 instance. So that's something we are working with the AWS team to enable. We also want to enable the custom images for the Studio kernels so that data scientists can bake in their Python packages or Linux packages so that they don't have to do that work every time they launch the kernel. And we also want to allow accessing Studio Notebook with the VPC endpoint to reduce the launch of Studio Notebook. And that's all I had, so I'll hand it over to Rekha for the new Studio UI features.
Thank you, Piyush, for sharing your story of how you've enabled SageMaker Studio in JPMorgan Chase and for your collaboration as well. So before we hand it over to Ram for a full demo of the product, which I'm sure you're eager to see, I also want to share some of the new features that we've just launched here at re:Invent and how we're making SageMaker Studio even better for you. So first, we have a brand new user interface for SageMaker Studio. So we told you about the host of capabilities that Studio has. Well, we've now made it easier for you to discover and get started with these capabilities. So you'll see there on the left navigation that we've introduced a new navigation panel, which follows the ML development workflow, so you can easily find exactly the tool that you want. We've also introduced new landing pages for every one of our tools, Data Wrangler, Feature Store, etc., which gives you more space to manage your resources, and also includes links to tutorials, blogs, documentation, because we've heard from customers that it can be cumbersome to switch over and do a Google search or a search within the documentation to find what they need. We've also updated the homepage here, so you have access to common tasks, workflows, and things that you need. So with just a few clicks, you can open a notebook or a kernel or image terminal. We talked to you about Data Wrangler and how you can visually prepare data within SageMaker Studio. Well, we're very pleased to announce that we've now integrated this capability right within SageMaker Studio notebooks. So you have this visual no-code data prep assistant available right within the Studio Notebooks interface. Next, to address the problem of managing clusters, we are pleased to announce serverless notebook kernels right within SageMaker Studio. So this is managed by AWS Glue, and you can interactively prepare petabyte scale data using either Apache Spark or Ray without ever leaving the SageMaker Studio interface or managing all of the infrastructure yourself. We also told you about collaboration and how SageMaker Studio is designed for collaboration. We've made it much easier for your teams to collaborate now by introducing real-time collaboration features within Studio. So your data scientists and ML builders can now co-edit, co-author, and comment on notebooks and share them within the Studio environment. And finally, we're also very excited to announce that we have a new SageMaker Studio Notebooks capability, which makes it easy for you to go from experimentation to production with just a few clicks. So within your SageMaker Studio Notebooks, you can author your notebooks and then quickly automate them with just a few clicks in the UI. So we're really excited to see how you're going to leverage all of these new capabilities that we've just launched, and hope you'll give us feedback on how it's working for you. Now let me hand it over to Ram for a full demo.
Right. Thanks, Rekha, for that walkthrough. Thanks, Rekha, for that walkthrough of exciting new SageMaker Studio features that will help our customers to be even more productive with Amazon SageMaker Studio. For the next 20 minutes or so, I will demo Amazon SageMaker Studio, end-to-end machine learning capabilities using a real-life problem, customer churn use case you probably are familiar with. My name is Ram Vittal. I'm a principal solutions architect. I help customers onboard scale machine learning workloads on Amazon SageMaker. Let me get set up with a demo in a second. All right, there you go. Excuse me. Rekha talked about the redesigned homepage. That's what you're seeing here on the screen. We have completely redesigned, re-architected SageMaker homepage. Basically, you see there are 4 sections on this homepage, starting with quick actions. You have Open Launcher, where you can click on it and then create a notebook or create a code console, open an image terminal, and a few other options you can see here. And you can also connect to a variety of data sources, such as Amazon S3, Redshift, and Databricks, Snowflake, and work with the data from those data sources. And you have options to get started quickly with guided tutorials and notebooks. And our pre-built and automated solutions, we provide quick start solutions such as pre-trained models, notebooks, and pre-built solutions from SageMaker Jumpstart. So you can just click on that and get started with a complete solution, like you see here for document understanding solution, or you want to do reuse some of the foundational models, such as Bloom models. We provide that to you. And then vision models, text models, tabular models, and many more. So you can quickly get started with that, pre-trained models. And then we also have AutoML, using which you don't have to do any algorithm work. You just feed a data set with the target column that you want to predict, and AutoML will automatically build the algorithm and pick the best model for you. It'll do multiple model iterations and pick the best one for you. So under the workflow and tasks, you can actually build the entire machine learning workflow. We have provided quick access to all of those steps here, right from preparing your data and then building, training, and deploying your models, right from here. It's an easy way to get to all of those functions. And also in the last section, we have quick start solutions, which is what I talked about earlier. So you can just get to a specific pre-trained model, such as image classification or object detection and so on, right from this screen. So let me walk you through quickly on the left navigation menu options. So you see data. Under data, we have a few options. We have Data Wrangler, which is a low-code, no-code tool that Rekha mentioned about. using which you can actually create a visual data flow diagrams and do, pull data from various data sources, do transformation activities, and prepare your data. I'll do a demo, dive deeper into that particular feature in a minute. And then feature store, basically as you're building your models, you're going to be preparing data and then creating features, right? So you want to store those features in a feature store, and then therefore you can reuse it across different use cases or across different projects. And then clusters, it actually gives you an ability to connect to EMR, spin up an EMR cluster, and then do any kind of big data processing that you may have to do for your data preparation work. So you can do that right from the Studio Notebook itself. I spoke about AutoML. That's the same function. We have quick access from here. And experiments is another feature we have, where when you're building machine learning models, it's an iterative process. So you may go through 10, 100, thousands of experiments, right? So the experiments feature, wow, that's a part of live demo, isn't it? OK. Yeah, so you can create hundreds and thousands of experiments, and then you can compare them and pick the best model. And then actually you can promote it to model registry and then start the deployment process. And then you can also do tracking of all of those experiments. We provide lineage tracking APIs, so you can actually connect all the dots as part of your auditing process if you need to provide that information. So. And then notebook jobs, it's a recent feature we launched where you can schedule notebooks, and then you can come to this place and then monitor those jobs as well and the definitions. Under pipelines, this is basically a feature that you have to wire all your machine learning steps, such as your data preparation, training, and evaluation, and so on. You can wire all of them together as a nice pipeline, and then you can run it locally in the notebook, and then you can get a DAG of that, as well as you can deploy it to a target environment and run your entire workflow. On the models, we got a few options. Model registry is one, where when you want to deploy, you are creating a version of your model, and model registry is a place where you want to centrally store it, and then you can version as you make changes, and then you can deploy the model. You can have a CI/CD process that kick in and deploy the model from using your model registry. And sharing models is another feature we recently added, where you can use Jumpstart to create models and notebooks and then share it within your organizations and teams, and that's a feature there. An inference compiler helps you optimize your trained models for deploying to cloud instances and edge devices. That's another feature. And deployments, under projects, we have that actually provides you a template. We have built-in templates that you can use to do automated CI/CD process and manage all your build and deployment activities. You can also create your own custom templates as well with SageMaker projects. An inference recommender gives you options to make recommendations for your inference deployments, such as instance types and configurations that you may need. It can provide you those recommendations. And endpoints is another feature we have that gives you, when you want to deploy your inference to an endpoint, if we provide managed infrastructure, we take care of auto-scaling the instances, and you provide, using the inference recommender, you can provide those inputs, and then we take care of deploying that and managing the infrastructure for you, including traffic routing and things like that. So quick start solutions, we talked about it, and then some learning resources. So you have access to all of these right from this redesign interface. So let me get into the demo of the example customer churn use case I spoke about earlier. So what I'm going to do is, I've prepared some notebooks. I've already run some of the notebooks to save time here. So here's a notebook that actually pulls data from a UCI repository. It's actually a mobile operator's data set that's available publicly, and it kind of tracks which customers are churning, right? So that's kind of the, and we'll be using XGBoost algorithm to do the churn prediction, which is a binary classification. So here I'm basically pulling the data set. I'm setting up the environment. I'm installing SageMaker. And you can see I'm pulling in, installing XGBoost as well. And then setting up SageMaker execution role for managing permissions. And then pulling in the XGBoost container. And downloading the data set, setting up S3 buckets, and then downloading data set, and then exploding it, and then uploading it to a shared S3, to an S3 location so that I can use it downstream in the data preparation step. So that's essentially just a setup here. That's what I've done. And once I've got the data set and it's in my S3 location, I can take the data set and prepare my data, transform my data for my model building activity, right? So that's kind of what this is doing. So give me a second. So in order to do that, actually, I'm going to show you something here with SageMaker Data Wrangler. You can use SageMaker Data Wrangler to build the data flow diagram like this. It provides widgets to click on it and then build this diagram. So here you can see I'm using source as Amazon S3 because that's where I uploaded my data set. And then I'm pulling the data set here, and this is the example data set. This is the actual data set, actually, that I'm using to build this model. So you can see here there's various attributes about the customer, the area code, the phone number, then the day charges, days, minutes they called, and so on, right? And then you will see there is a churn flag at the end that tells whether the customer is going to churn or not. So that's your input data set. And then you want to do some kind of transformation, right? So then what are some of the transformations we can do? So we support up to 350 plus data transformation activities you can do using SageMaker Data Wrangler. So here you can look at the data types. What are the input data types? You can see here all of those data types in the input file. And you can actually change those data types too if you need to. And then you can, before you go on to do a data transformation, you may want to do a data analysis, and Data Wrangler supports that as well. So you have various data analysis options. Here I'm showing you a couple of those, like table summary. I may want to know how many records are there in my file, what's the account, and what's the mean, average, and that type of thing. So that's kind of what the table summary does. And you can do histogram and various other data analysis on your data set. So once you got a grasp of your data set, you can actually start to apply data transformation activities. So here I'm actually, so you can see here, I'm dropping a few columns, like some charges and things like that here, which are not really going to contribute to my model prediction. So. And then also I'm adding, you can chain all your data transformation steps, like click on the plus, and then you can add a transform step, something like that. And then you can go and add a step. And you can see all these transformation activities here, right? So you can see, you can do sampling, you can do split data, you can do time series, you can do handling outliers, handling missing data, and so on and so forth. So there's quite a few transformation activities supported. So. And also you can do custom, right? So one of the custom activities you can do is you can plug in PySpark code or a Python code or something like that. And so here I'm doing Python pandas. I'm doing a one-hot encoding activity here. You can see a snippet of the code. Basically, I'm turning that Boolean flag churn into a numeric value because when you're building models, it has to be numbers, right? So it's transforming that. That's all it is doing. So you can see here as an output, the churn has been changed into a 0 or 1. Originally, I showed you it was a true or false, right? And also, you can see all of them are numbers, all of the inputs here. It has done a one-hot encoding as well. You can see all the states have been transformed to zeros or ones. So that's no code, pretty much, very light low code, right? So you can just use Data Wrangler to do that. And we have other options too, like the EMR options if you're doing heavyweight processing. We also have serverless glue now, interactive glue, you can use those too. So you got options there, Athena too you can use. So moving on with, so once you've done this, you can actually simple click here, right? And then you can export, right? You can export it to a Jupyter notebook, or you can export it as a SageMaker pipeline and run it, or you can do just Python code off of this. Or the last one option is to directly feed this data, prepared data, to a feature store, right? That way you can reuse it for training and inference later on. So you have all those options. So what I chose here was just click on this and get a notebook out of it. So then it's basically running that as a processing job, which is basically a serverless transient cluster that spun up as a Spark cluster, and then it runs that code there. So that's this code. I've already run this, but here's an example of that code. So if you look at that, so here I've run this code earlier. It's the same code that I showed you a while ago. And then I'm basically uploading the flow diagram that I created. It's uploaded to S3. And then feeding all the inputs, the data sets that we created earlier, and then running the processing job, right? Which is basically a Spark job. So and then you can see the outputs. Here I'm creating the processing job, setting up the processor, and then doing processor.run. And that actually runs the Spark job behind the scenes. And here you can see the output to an S3 location. So it's taken this input raw.churn text, and then it'll generate the output to the output location. And that's the data processing step. So now we have the data, and also as part of the data processing, we split the data into train and validation data sets as well. And then once we have that, we can go into a modeling activity and start doing model training, right? So we want to build a model for customer churn. So here in this notebook, what I've done is basically taking that input data set that we created in the previous step. And you can see the train.csv and validation.csv, which was actually comes from the data preparation step. And then you can actually train the model. You create an experiment first, right? So experiment.create, and then you set up some hyperparameters. So that's the next step. And then you run trial, right? You trial.create, and then you create the estimator. So in this case, it's an XGBoost model or algorithm. So then I run the estimator and then do an XG fit. I call the fit method to actually start the training. And here I've already done the training, you can see, and it's gone through that process, and it's already done. It's completed. And actually, it spins up a cluster, right? So it's a transient cluster again. And you're actually billed for the time the training cluster runs, not anymore, right? So here you can see it's only 62 seconds. That's the time you're paying for those clusters. Okay, so now we have built the model. So the next step would be to, so if you want to see this on the interface, right? So you can actually go back to this UI and look at experiment, because I created an experiment, right? Where is the experiment? So you can see here, I've run a few of them earlier. So you can see that customer churn prediction is an example of that. So you can see here number of training steps, because I've done multiple iterations. So every time you run a training trial run, it creates an entry here. So you can see here the training has run. There is a validation loss. There is a training loss, right? You can see the metrics here. And you can also create charts if you want to. Here, I don't have a lot of data points, but if you had more data points, we can create charts. And you can see the output artifacts. Where did the model artifact land on S3? And you can also set up debugs and then monitor debugging as well. And then you can see all the settings that went into creating that experiment in terms of what the image you used, the instance type, and all other parameters. And here, my objective metric, you can see it's binary logistic. You can also look at the configurations that went in there, and input artifacts, and metadata, right? All of that is available to you through the experiments UI. And also, you can compare multiple experiments too in the experiments UI by selecting like this. It's an example of one of the other experiments I ran. So you can just click on this and hit analyze. So you may have multiple experiments that you run in order to build a model, and then you can see the results across those experiment runs. You can do that. And yeah, so then you also have something called unassigned runs, so which is basically the processing jobs that you're running, right? So that kind of comes into an unassigned runs. You can see here for the data wrangler processing job that I ran, there is an entry here. So that's that unassigned run, and you can do monitor the metrics here as well. So then let's hop back to the exercise. So now I've trained the model. The next logical step for me to do would be to evaluate, right, how well this model is going to perform. So you can run an evaluation. So you can use notebooks to do that, right? So here is an evaluation notebook that I have run through earlier, and it's basically evaluating the model. It's actually pulling in the tar file, right, model.tar, and then it runs, and then it does a pickle load, and then it evaluates the model, running predict function on it, and see how well that model is performing. So you can see some of the results here, accuracy metric and AUC metrics. And then we also created a classification report as part of that evaluation. So you can see the classification report is a JSON file here. And you can also put this into a Python script and then run it as a processing job. But eventually, you're doing this interactively, but you want to schedule this, right? So you can do that by wrapping that into a Python code and running it a processing job. And you will see later that how do we wire all of these into a pipeline series of steps. You will see at the time how this works. So that's evaluation. And then after that is deployment, right? So you are satisfied with your evaluation, so you decide to deploy it, or host it, right? So that's the next step. So you have a couple of options. You may want to choose real-time or batch, depending on your use cases. So here I'm just going to show you how the real-time works, but batch would be like a batch process, like a batch transform job. So here you can see So if you want to deploy it, so you want to host the model, right? So basically, I'm setting up the Bodo 3 here with SageMaker, and then hosting the model, I just call the XGBoost deploy method to deploy the model with the parameters I'm passing here is what's the number of instances I want to create, and what's the type of the instance. And then here also I'm turning on data capture, which is basically if you want to monitor your endpoints for performance. How well is it performing based on my expectation? Is it accuracy metric as good as I expected it to be? Is it deviating from my expectation? So you can do data capture and monitor that. So that's an option you have as well. And you can invoke the model once you've deployed it to that endpoint. You can invoke the model by a simple command here, as you see. And then here, I'm just doing that through a for loop. And you can see the predictions here. This is the probability the customer is going to churn, right? So, and then you can verify the data captured through this logic here. So you can see here, the data capture basically captures the entire input and output. So that's the deployment piece. So you can actually see the deployed model as well if you want to go to the interface and look at endpoints. So you can see here I have deployed a few endpoints. So you can see it's in service. And yeah, so you can also test the inference from here. We have an interface. You can feed in the request and test it. You can also monitor the model for data quality and model quality, model bias and things like that. And you can look at the settings, what have you used to deploy that model, all of that here, like the data capture I've set up, and the endpoint settings, configuration settings, and the production variants, like how do you want to regulate, control your traffic to the endpoint. So all of that is available to you here. And then, so once I've deployed, the final step would be to put all of them together into pipeline, right? So that's the step you want to do finally. So getting into pipelines, so you can see an example of that. So here you can see we started with data preparation step, right? So that's the first step. I'm bringing that together to wire all of those steps into a series of pipeline steps. So that's kind of what I'm doing here. You can see here it's a processing step, a training step. I'm calling those workflow steps here. And then setting the processing step up, data processing step here. And setting up some parameters such as what type of instance type I want to pass, processing instance count I want to pass for the data processing step. And then I'm setting up the processing step itself here, all the configurations that you need for the processing job, the train, the validation, and the test as the output. And then I'm creating an experiment config, and that's pretty much the step for the data preparation, okay? And then the next step would be to set up for the model training, and that's this step. I'm setting up the estimator with those inputs, and then I'm creating a training step with the training input, and then the validation inputs. And then, so that's you've set up the training step, and then the evaluation step. You set up the evaluation step using the same processing step, similar processing step that you've done for training as well. And then so now we've done 3 steps, and then you can put them together in a pipeline as you see here, right? So you have the step process, step train, and step eval. So you basically string all of those steps together, and that's how you put together the pipeline. So and with these parameters. Now you're not ready to deploy yet or run the pipeline yet because you probably want to think about approving and registering the model as well as the following steps. So then that's the 4th step. You want to set up some kind of a condition here to check how well the evaluation has gone through. Does it meet my threshold? So you can do that with this before you register the model. You want to do a conditional evaluation. So that's kind of what you're doing here. You're doing some conditional checks. And then you're actually to create the to register the model. When you register the model, you also want to create some metrics around the model, like what is my accuracy metric and AUC metrics. So you're setting that up here to register. So you're registering the model along with that information. So here you can say, you're saying what type of inference instances I'm going to be using, the transform instances. All of that information can be provided to when you're registering the model along with the model metrics and approval status. And then you create the condition step for your accuracy threshold. Here I set the accuracy threshold to 0.8. So if it's more than 0.8 or more, then it will register the model, otherwise not. And then finally, I'm just putting all of those steps together, the pre-processing, data processing step, the training step, evaluation, and then the condition step. And that's how you put the pipeline together. And once you run it, so you can just do pipeline.start here to start the pipeline. And you can actually look at the pipeline itself in this UI. So if you go down to pipelines, you can see here the pipeline I created earlier. It's called churn ML pipeline. And if you select one of these that I've run earlier, you can see a DAG, right? So here you can see the first step was the customer churn process, which is the data processing step. You can actually click on it and get more information about that step itself, what the inputs were, what the outputs are, and also you can get the logs to the CloudWatch logs and things like that. So it's an easy way to troubleshoot as well your pipelines. And then you can, then we did the training step, right? So it kind of feeds into that. And then once the training is done, and then I did an evaluation step that you can see here. And then after that, we did a conditional evaluation, right? So we said whether the accuracy is more than or 0.8 or more, then I go, it's true, then I do the model registration, right? So that kicks off your CI/CD process to deploy the model. So you can actually see the model registry as well. So here, right? So if you click on the model registry, you can see here there is so model registry is the concept of package group. You create a package group, and then within that you can create multiple, register the version of your model. You may have multiple versions depending on how you're iterating on your model. So here you can see I've created one version, and then you can see the model metrics here. Like, for example, here, what activities are performed, what's the status of the model is. Here it says status updated to pending. And then model quality metric, the one when we registered, we also provided model metrics, such as the accuracy and AUC metrics that you can see on the model registry as well. And yeah, and then you can see other settings about your model, right? So all the metadata about your model itself, which is available here. All right. Yeah, so once you have done that, then the next step would be your model is, somebody has to go approve your model in your model registry, and then that will kick off the CI/CD process, whether you're using Jenkins or code pipeline, whatever you're using, that process will kick off and deploy it to your target environment. So that's the whole life cycle. So that's the demo I had. I think we'll flip it to. That a quick recap on the session and some highlights. We talked about SageMaker Studio, the universal IDE for machine learning. We walked through the various machine learning lifecycle steps, such as building the model, training the model, tuning the model, and using the single visual interface. And also we spoke about some of the integrations with EMR and Glue, how you can do big data processing at scale using Studio IDE, and how you can run large training jobs and deploy your models right from Studio IDE as well. And you heard from JPMorgan Chase how they securely deployed their models using SageMaker Studio to hundreds of accounts and users. And we have some upcoming related sessions as well, which you probably can see on the screen, so if you're interested.